Hello everyone, thank you for taking a few moments to view this video. This is the second video that we'll look at to help us begin to develop an understanding of experimental research. Now, as we go through this video, one of the first things that I'd like to talk about first is this idea of a hypothesis. Now, we talked about this early on when we looked at both inductive and deductive reasoning. And so I want us to visit this concept here because hopefully this will help to bridge the gap between what we first talked about and what we'll continue to talk about as it relates to experimental research. Now, the first thing that I'd like you to take a look at is what this idea of a hypothesis is. One of the things that you've probably heard in your educational career is that our hypothesis is an educated guess. But I want to maybe elevate that definition just a little bit. Perhaps the best way for us to elevate that is to look at the definition that you see here on your screen. Our hypothesis is the tentative explanation of the outcome of the research problem. Now, it is generally important to include this or to put this in most research studies. Now, sometimes it's actually best to leave a hypothesis out. And so here's what I want to give you real quick as we go through this content. Generally, what we want to do through qualitative research is to generate a hypothesis. Now, on the other end of the spectrum here, we oftentimes will talk about research being quantitative. And for the most part, with quantitative research, we are trying to test a hypothesis. So in this instance, we typically would state a hypothesis. Now, when we state our hypothesis, we do have a few things that we want to be true of that hypothesis. We want it to be a simple and clear statement. In other words, we want to use terminology that's easy to read, easy to recognize. We want to make sure that our hypothesis is testable. In other words, we're not married to a specific hypothesis. We're willing to do away with it if for some reason it doesn't hold up through testing. And then lastly, because of that, we want to make sure that our hypothesis is something that can be refuted. In other words here, we don't want to hold on to our hypothesis or our expectation of the outcome of a study. We want the research to speak for itself. Now, one of the things that we'll take a look at next are the two different ways that we can state our hypothesis. So we can state it in one of two ways. We can state our hypothesis is either being a directional hypothesis, or we can classify it as a non-directional hypothesis. And so if we're looking at a directional hypothesis, as you can see here on the screen, it's going to be one that the researcher uses to indicate that a specific direction will occur because of his or her study. In other words, we will utilize a directional hypothesis if something within the literature that we've read points us to that specific direction. Or we could say that we'll set a directional hypothesis if we have personal experiences that point us to a specific direction, or if experience from other people point us to a specific direction, then we'll use a directional hypothesis. So there are going to be instances where we may not have sufficient information to predict what may happen. And in those instances, we say that we'll use a non-directional hypothesis. And so again, this is something that we use when we're not sure of what a potential outcome of the study might be. And so sometimes it is difficult to make predictions upon a study. And so sometimes you may see this more often than there being a directional hypothesis listed. So let's look at an example to see if we can make better sense of what we've talked about so far. Let's imagine that we start here at the very top. We have a gentleman that's coming through the door. We can say about this gentleman that as he comes through the door, he is either going to look to the left or he's either going to look towards the right. And so again, this becomes our example of a non-directional hypothesis. And so the reason that we say that this is a non-directional hypothesis is because we have not set a specific direction by which this gentleman will look. We've said that either a look to the left or a look to the right might occur. So again, we haven't set anything in stone. So that's our non-directional hypothesis. Now, for the directional hypothesis, you'll notice that based on this image, we can actually set this in two ways. We could say that as the gentleman comes into the door, he will only look to the right. And if we say that he's only going to look to the right, we've now made a directional hypothesis. Again, we've just simply stated with certainty what we believe will happen. In much the same way, as this gentleman comes through the door, we could say that he's only going to look to the left, and that also would be a directional hypothesis. So going back for just a second to the example that we gave, we utilize a non-directional hypothesis when there is insufficient information to help us predict what's going to happen. But on the flip side, we use a directional hypothesis when there is sufficient information to indicate what the outcome may be. And so remember that sufficient information is going to come from the literature that we're looking at. It's going to potentially come from a personal experience that we've had, or maybe the experience of someone else. So let's look at a third type of hypothesis, and this is the area that we'll spend most of our time in. This third type of hypothesis is what we call a null hypothesis. Now, there is something that I'd like you to get right off the bat here. This type of hypothesis is only for statistical purposes. And so, just in case you didn't quite get it the first time, it is only existing for statistical purposes. And just once more, so that we hammer this point home, it is only for statistical purposes. In other words, when we talk about this null hypothesis, it is not necessarily going to reflect the expectations of the researcher. And I believe this will make sense here in just a moment. Now, this other point that we have here indicates for us that we utilize a null hypothesis to allow us an opportunity to describe whether or not there is a difference or a relationship between the independent and the dependent variable. So if you will, allow me an opportunity to showcase what a null hypothesis would look like. Now, to help us, there is a specific phrase that we'll need to become familiar with. And in order to help us generate or to develop a null hypothesis, all we'll have to do is take this phrase and plug it into our sentence. So here's the essence of the null hypothesis. The null hypothesis will always say either there is no difference between the independent and the dependent variable, or we might see that it says there is no relationship between the independent and the dependent variable. So Let's go just a little bit deeper into this by looking at another example. Let's start with this question. What do we do with a null hypothesis? So you may be saying, okay, I understand that this is for statistical purposes only. I get that, you told me 3 times, but what do I do with it? Well, the good news is that we really only have 2 options when it comes to handling a null hypothesis, and we'll talk about that momentarily. But let's look at this example. Imagine that we've just administered a statistics test to biology majors and to mathematics majors. So here's kind of the question. What should our research hypothesis be? Now think about this. Remember, we have either a directional hypothesis that we could use, or we could make this a non-directional hypothesis. So let's just kind of use our own intuition here, and I guess we could say common sense. What should we say our research hypothesis would be? Well, you're probably right. We should say that there is definitely going to be a difference between these two, and specifically, we would probably say something like this. And feel free to write this with me. We would say, it is hypothesized that the mathematics majors, and I'll just abbreviate math for short, it is hypothesized that the math majors will have higher scores than the biology majors on the statistics test. I think that we could agree that that's certainly a fair statement. So let's double check ourselves here. We have said it is hypothesized that the math majors will have higher scores than the biology majors on the statistics test. So let's look at what we said. We said the math majors will have higher scores. So because of that, we have listed a directional hypothesis. Okay, so hopefully that makes sense. Now let's take a look at the one just below it, which is the use of our null hypothesis. Now, our null hypothesis, again, is going to have the phrase no difference or no relationship. So we could use either of those for now. So let's use no difference. So we would say there is no difference between the scores on the statistics test based on being a math or biology major. So again, the way that we know we've got our null hypothesis is to say that there is no difference between our independent variable, which would be the statistics test, it's our independent variable, and our dependent variable, which would be the scores. So as long as we have those 3 things within our null hypothesis statement, we're on the correct path. So let's switch gears for just a moment here to make this even more practical. Let's imagine we have the very same scenario. What we would do in order to determine whether or not there really is a difference between how well the biology majors performed and how well the math majors performed, we need to use some statistics. And one type of statistic that we'll learn more about this semester is something that we call the independent t-test. Now, I'm going to spoil it just a little bit here for you. The independent t-test is a test that we utilize when we have one continuous and one categorical variable. And oftentimes, this categorical variable has two groups. So let's think about that for just a second. If we are to investigate what makes up this continuous variable based on our scenario, that would be the scores from this test. Okay. Now, when we talk about the categorical variable, if we needed to utilize an overarching general term, we could say that our categorical variable here would be students. Now, we've also said that this test allows us to see whether or not there's a difference between two groups. And so our two groups as it relates to this scenario would be our math majors and our biology majors. In other words, our biology majors and our math majors represent levels of the variable for students. So again, as we talked about earlier, we only have two options when it comes to dealing with this null hypothesis. And those two options are written right here on the screen. We could either do something that is to reject the null hypothesis, or we could do something that allows us to fail to reject the null hypothesis. And so we're going to deal with these terms here in just a moment. So let's talk about this. Why do we have these two options? Again, our options are to reject or to fail to reject the null hypothesis. And so what I want us to do here is to take a moment to understand the difference between these two. And something that I think might actually help us here is if we look at a real world example first. And so what I'd like you to think about is the courtroom. Now, you're probably familiar with the fact that in our society, there is this notion that you are innocent before proven guilty. So, if you are writing, if you would, please feel free to create this schematic with me. So, again, here's what we're saying. We are innocent until we are proven guilty. We'll put a line here. Okay, so we are innocent until proven guilty. So I'll just kind of ask this question. What is it that stands between someone being innocent and being declared guilty? Well, if we think about it, what stands in between these two is a trial. And so when we think about this trial, really what this is a testing period. Okay, so we've got this testing period that exists between us being believed to be innocent and whether or not someone or we are proven guilty. Now, in the criminal justice system, what happens is once you're on trial, there is kind of two options that happen. And you probably already know where we're going with this. You are either declared not guilty or guilty. Okay, so here's something that I'd like us to think about for just a moment. As soon as we go into this process of maybe being on trial, again, we're here, we're innocent. Now, the very moment that the trial begins, now we're here, the very moment that the trial begins, think about it this way, we're actually on our way towards being proven guilty. And so the reason I say it like this is because on trial, people are looking at evidence, they're going through any kind of information that they can to see if you really are guilty. So again, here's what we're saying. If you're on trial, you can think about it this way, that you're almost on your way to being declared guilty. Now, at the end of that trial, because you're kind of on this track already, the options is that you are either not guilty or that you are guilty. So let's unpack this for just a moment. And I'm sure you all know this very well, but being declared not guilty kind of means two things. It either means that one, someone is innocent, and I'm sure you're probably already thinking it. It also could mean there wasn't enough evidence to prove that someone is guilty. So again, not guilty means that someone is innocent, or it could mean that there isn't sufficient evidence to prove otherwise. Now, the other outcome is that you're guilty. And what this means is there is sufficient evidence to say that maybe you did commit the crime. And of course, we could also make the comment that just being declared guilty doesn't necessarily mean that you've done the crime either. But just for this purpose, we'll leave our schematic just like this, because I think looking at it this way will help us understand what we mean when we talk about the terms reject or fail to reject. All right, so if you've still got your pens or pencils out, let's do one more schematic here to hopefully give us an understanding of what we're talking about. So let's look at it from a statistics point of view. In much the same way for statistics, we kind of go from this period of accepting a statement as being true, and we have this process again, and we've got on the other end of this rejection. Okay, and so again, just like we said before, there's something that stands in between acceptance or being accepting and rejection. And that would be, again, a trial. Now, in research, we have another term for it, and we'll definitely look more at this as we go through the semester. Oftentimes, we refer to this as hypothesis testing. Okay, so as we go through statistics, it's much the same way as we've talked about with the court case. Again, we go into this accepting that a statement is true. Now, as we go through this trial here, again, much the same way, we're on the way towards rejecting something. Again, because we're testing it out, we're doing very rigorous techniques to make sure that we are correct in whatever we decide. So by the end of this process, it's going to be much the same. We're either going to decide to fail to reject something, or we are going to reject something. So again, if we are to fail to reject something, what this really means is that one of two things: it's false, or it could mean that there's not enough evidence to prove otherwise. So when we talk about there not being enough evidence to prove otherwise, there is a special term that we use in statistics, and we say that something is not statistically significant. Okay, and that will be a term that we come back to later on. Now, the other end of this is that as we go through that process again, we can reject something. And if we reject something, it usually means we do have significant evidence to reject a statement as being true. So I hope that this concept helps us think through this a little bit more practically. Now, I don't want you to get too hung up on these concepts here. As we go through the semester, we're going to do some statistics and we'll do some testing, some hypothesis testing. And I think as we go through that, you'll begin to develop a deeper understanding of what we mean by these terms. So now let's turn our attention to something different here for just a second. I want to show you something that we call the truth table. Now, this truth table helps us to understand what we do with the null hypothesis, and it helps us to know whether or not we're doing the correct thing or not. So let me explain this for just a second. If we have a null hypothesis, and remember the statement for that null hypothesis is going to say either the terms no difference or no relationship. And I'll just abbreviate for our purposes here. Again, that null hypothesis will say that there is no difference or there's no relationship. So again, as we think through this, if we come to find out that a null hypothesis statement that has one of these two phrases, if it is true, what we should do is fail to reject that statement. So in other words, if a null hypothesis is true, we're going to essentially accept that statement. And so that's really what we're saying when we talk about fail to reject. We're accepting that it's true. Now, on the flip side of that, if we have a null hypothesis statement that is false, what we should do is reject that statement. Okay, so this lets us know how we handle things. If it's a true statement, we accept it. If it's a false statement, we reject it. Now, there are instances that we'll come across by which it's possible for us to make an error. And the way that we make these errors, you can actually see listed to the left-hand side of your screen here. We have what we call either a type 1 error or a type 2 error. Now, this type 2 error, as you can kind of see here, looking towards the bottom, this type 2 error happens when we fail to reject the null hypothesis when the null hypothesis is false. So in this box, we'll put type 2 error. Okay? So again, if we fail to reject or if we accept a null hypothesis that's false, we've made an error. Because keep in mind, we've already said just a moment ago that if we have a null hypothesis that's true, we want to accept that. Now on the flip side, the other type of error that we can make is a type 1 error. And this type 1 error happens when we reject the null hypothesis when the null hypothesis is actually true. So in this box here, we'll put type 1 error. So again, hopefully that begins to make a little bit of sense. Now, maybe let's unpack this just a little bit further so that we make sure that we have an understanding here. So let's look at this game, and we're going to call this the guessing cup. And so here's kind of the question that leads us in this game called the guessing cup. The question that we're asking is there a red dot under the cup? So let's think about this for just a moment. Again, we're asking, is there a red dot under the cup? So again, we're playing a little bit of a guessing game here. So let's imagine that anytime we put a red dot as our guess, kind of on this second row that you see, we're saying that we're positive that there's going to be a red dot inside the cup. Now, if we don't put a red dot as our guess, we're going to say that we're not sure. And kind of our term to represent that will be the word negative. So let's think about this. Let's look at our first cup here. For our first cup, let's go ahead and put our guess. Let's guess that we're positive that there will be a red dot under the cup. So again, imagine that this cup is turned over and we look underneath it, and guess what? We find that there's a red dot. So here's how we'll put kind of our response for this. We'll say that because we're correct, it's true. And so remember, because we put our red dot here, we essentially are saying that we were positive about it. So our positive that we had is certainly true. So let's take a look at the second cup here. Let's imagine that for our second cup, we guess that there is a red dot here. And let's imagine that we follow this up by turning over the cup just above it. And let's imagine that we actually don't see a red dot in that cup. So now what we have to do is say that our answer was wrong. And the word that we'll use to represent that is false. And so we've got to put our qualifier here. Because we put the red dot, we said that it was going to be positive. So our qualifier here is that we have a false positive. Let's do it one more time. Now, for our third cup here, let's imagine too that we think, I don't think there's going to be a red dot this time. So again, we don't put anything as the image below the cup to signify that we don't think anything is going to be there. And again, imagine that we turn over this third cup and we see that there is no red dot. So what that means for us is that we were correct. We didn't put that there would be a red dot, and there wasn't a red dot. But our second qualifier here is the fact that because we didn't put a red dot as our guess, this was negative. So the way that we'll qualify this is to say that this is a true negative. Now for the fourth cup, again, we're kind of going in the same direction for this. Let's imagine that we think, okay, there's probably not a red dot in this cup. And then again, if we turn over that fourth cup, let's imagine that we find a red dot there. Well, turns out that we were wrong. So the term that we need to use here is false. And so because we didn't put our guess for the red dot, we said that it would be negative. And so the way that we qualify this is to say at the end here that we have a false negative. So let's kind of go back for just a second to these terms, false positive and false negative. When we talk about this false positive, this is analogous to us saying that we have a type 1 error. And for our false negative here, this is analogous to us saying that we have a type 2